back at ETHDenver. It's another year. And what's different this year than last year specifically, what we're going to be talking about today is the continued evolution, the expansion of the modular ecosystem. This thing that this time last year was really just an idea, today, this time in 2024, is really starting to materialize and take shape. So why are we here? We're here, the proximate reason for us being here today is because all of us find these internet computers pretty cool. Sorry, my slides keep moving around. Don't know why. We think they can have a real global impact, and we think that they are the means to perhaps creating a new financial substrate, a new substrate for computation. But by this time in 2024, we've seen the pitfalls of their inherent design. And back to this question of why are we here? Well, the proximate reason is yes, we want to advance this thing. We think it's cool. We think it can have a real impact. But the bigger reason is we're all here because we're trying to increase demand for these internet computers, for these blockchains. Everyone here is probably spending most of their effort, a lot of their life force, in advancing demand for these systems in a way, in an effort to try and make them achieve this global impact that they can have. So depending on the audience, sometimes I go deeper into this. We're not going to have to do that today, but I love this visualization here from Tick Street showing blockchain transactions as different buses and bus lines. Even before they created this, I always thought that the bus line analogy is a really nice way to think about blockchains. Every blockchain is a bus line. Each block is a bus with a fixed amount of seats representing the block size, the gas allowance, the cadence of the buses coming in on that line being the block time. But unlike buses, which kind of take a fixed market price in a first-come, first-served basis, our buses have similarly a fixed supply of seats, but pricing not first-come, first-served, rather determined by the market. And we know what happens. We know what happens whenever we're a little bit successful in our quest to increase demand, we run into the same problem. This problem that in a way is really counterproductive to our entire effort because we increase demand, supply stays the same. Now we run into the same issue each time. The gas is too damn high. The networks become unusable. And we kind of shoot ourselves in the foot with respect to being able to scale this thing to a global impact. So by now, we have two general approaches for how to deal with this problem. One is let's build bigger, better, faster buses, the monolithic approach, as some like to call it. The other, the modular approach. Let's create many, many, many more bus lines. Within each type of bus line, let's enable more customization, different types of buses, different seats. And what that's leading for us to create is the early innings of this modular ecosystem. And so where are we with this modular ecosystem? Well, arguably no one's done more for this than Celestia, not just through their technical work to create the first alternative data availability layer, but also through the hard-nosed work of ecosystem building, which I can tell you as someone immersed in this every day, might be just as challenging, if not more challenging, than the technical work of getting this type of thing to work. But it's not just them. It's a wide array of teams, whether it's Arbitrum and Off-Chain Labs, Optimism and OP Labs, each creating their own rollup framework in Orbit and the OP stack, respectively. The different rollup providers in folks like Caldera, Conduit, Altlayer, and several others. And just a whole host of different players that are working on these solutions that are advancing the modular ecosystem. So I'd argue that the modular ecosystem has sort of had its big bang moment, its inception of the universe in Q4 of last year. A culmination of events with Celestia's launch, giving us the first live alternative data availability layer, continued progression and maturation from the rollup frameworks in Orbit and the OP stack, an improving of the offering to become more robust from rollup providers, again, like the Calderas and Conduits of the world, and a mix of different contributions by other players in this ecosystem. All of this serving to make the act of creating a new rollup or chain increasingly easier. So where are we today? Today, I would say that we are past that Big Bang moment and entering the first expansion phase of this universe. In the months since that Big Bang had occurred, what's been happening? As we've entered this phase, we're seeing more rollups and more chains, again, driven by the lower costs to create those chains, the increasing ability to do so. We're seeing more customization and experimentation at each one of these. Where is this going to take us? Coming up this year, we're going to see additional launches for data availability layers with the likes of Avail, EigenDA coming online. And as we continue with this trend, we think as the modular system expands and evolves, we're going to get sovereign rollups, an expansion beyond just the smart contract rollups we have today that are only tackling execution to also include settlement in that. Beyond that, we're going to see bona fide ecosystems building around these new rollups, each with their own merits, their own communities, their own norms. And so where do we get to beyond that phase? Well, I'd say that beyond that, the mere notion of a modular ecosystem in and of itself, that's going to begin to fade. Kind of like if you've ever heard David Foster Wallace's famous commencement speech, where he talks about the two fish swimming in water and encountering an older fish who looks at them and says, "Morning, boys, how's the water?" And the fish, they keep on swimming and they look at each other and they go, "What the hell's water?" Right? As this continues, as this expansion builds on itself, everything is going to be built in this way such that stating it, talking about the modular ecosystem in specific terms is going to lose its meaning because it becomes so pervasive. It's like the water that you're swimming in. It's the thing that surrounds you. So how do we get there? Well, I'm here to tell you how we at Hyperlane intend to pour gasoline on this budding modular fire that happens. Specifically, how Hyperlane's permissionless interoperability is going to be the thing that connects all the moving parts in this modular expansion. So I've argued before, may have had, if you've encountered some of our writing, some of Celestia's writing, that I think that talking about the modular stack without talking about interoperability is nonsensical. We just went over how different efforts are making it increasingly easier and easier and easier to spin up a new rollup, a new chain. Whether it's because the cost in dollars, the cost in developer cycles, the cost in time keeps going to go down. Whatever it is, we now have an increasing array of rollups and chains coming online. But what we don't talk about enough, especially when we talk about this notion of the modular stack, is interoperability. Yes, we're making it easier to create your own rollup. Yes, you can get one done in 5-10 minutes. But if it doesn't have interoperability, if it can't connect to anything, you basically created an island in the middle of the ocean. Don't you want to have trade routes between it and the mainland, between it and other island networks? Don't you want to have a path for economic activity? Of course you do. So how is it that we don't talk about interoperability as being a part of this stack, right? Again, that's why I'd say it's nonsensical. So interoperability changes that. Interoperability allows all of these things to connect. But it's not enough. In 2024, I'd argue it's not enough to simply have some way to connect these. You need a permissionless way to do it. You need a way that has no gatekeeping, that preserves the core concepts of crypto, of permissionless and sovereignty. You want to be able to connect without gaping on your terms, however and whenever you want to. And so that's what we believe here at Hyperlane. Hyperlane was built specifically for this world of many, many chains, this world where there's not just a lot more chains, they come to market at an increasing rate. And so we basically ended up building it for the modular expansion before anyone even knew what those words meant. Today, anyone in this room can deploy Hyperlane to any chain they would like. If you're feeling bold, scan that QR code, and what you'll find is a guide for how to use our CLI to deploy Hyperlane between two local networks. If you're feeling extra bold, you could scour the docs and easily find a guide for how to do this on a live network, not just local networks. I'll leave it to you whether you want to do it on a test net or a main net, but have at it. So if you don't already know about Hyperlane, let me tell you about Hyperlane, the one truly open framework for interoperability. So here we have a little schematic of the architecture, kind of going over it at a high level. Again, due to time, we're not going to go deep into the weeds here, but we'll cover the basics. Probably the most interesting thing to know about Hyperlane, beyond the fact that it is permissionless, beyond the fact that it changed how people think about security and interoperability, which again we'll spend more time on soon. Once Hyperlane is deployed on any chain, it can be connected with any other chain. And Hyperlane security works in the outbound direction. So you have a Hyperlane deployment on, say, Ethereum. You have a security module observing that deployment. Then any message going out that is signed off on by that security module, it can be, think of it like a broadcast. That broadcast can then be received by any other chain that has Hyperlane. In that sense, the Hyperlane mailbox function is both a broadcaster and receiver of interchain messages. So how does it work really? A message is constructed by a sending contract, often initiated by an end user, and then sent through the mailbox. A security module, which in just a minute we'll cover that in more detail, observes that mailbox, and if everything looks kosher, signs off on the message. At that point, it can be picked up by a relayer. The relayer is a permissionless role, can be ran by anyone, does not play any role in the security of a message. Pure and simple, a delivery guy, one that can't meddle with the contents of your package. So it sees that you sent something, it sees that it's been signed off by at least one security module, then it takes the necessary information from the security module, takes the message, and initiates a transaction on the destination chain, interacting with that mailbox. If everything checks out, the signatures look good, that message is going to arrive on our destination. Again, anyone can run a relayer. We're even working on features to let users relay their own transactions if you want. If you took my challenge of scanning that QR code earlier, and you're now fiddling around with the CLI, very soon you'll be running a relayer yourself. So what's unique about Hyperlane that makes us so convinced that this is the right way, perhaps the only way, to connect this vast and accelerating modular expansion and do so at scale? Well, it's this notion of modular security for modular chains. So Hyperlane does security differently. Historically in interoperability, pretty much every protocol took this approach of, we have a product on one hand. The actual product from these protocols is the connectivity between chains, the interface for sending some information between two chains. And then tightly couple that with the security mechanism, oftentimes enshrined directly in the protocol, such that the two are tightly coupled and basically inextricably linked. Starting with Hyperlane, this was decoupled. We felt there's no good reason to do this other than, well, it's just how it's been done. People come to these protocols because of concern about security. Tightly couple those two things. Why not? we've been in crypto long enough, right? Most of our teams going on year 5, 6, 7. And one thing you know is whenever you think you've just cracked things when it comes to security, that you've just designed the state of the art and no one's going to be able to figure it out, you're just a few months, sometimes even less, away from someone more clever with more time on their hands figuring out how to break that thing you wanted. So enshrining a security module never made sense to us. And we're glad that in the year since Hyperlane's launch, we're now seeing other teams taking this modular security approach. So at their core, Hyperlane security modules, all they really are wrappers on some logic that expresses either a state attestation or a state proof. You want to know that you can read state from another chain and act on that state, and you want to have something telling you why you should trust that state. Now, whether it's, you want to use some validators that you know and trust to secure your message, trust their authority, go ahead. You want to ask them to put up a stake and provide economic security, whether it's your own or it's inherited through ETH, through EigenLayer, through something like a Hyperlane AVS, even better. You want to use that groundbreaking new ZK technology. All of those can be expressed as Hyperlane module. Now, in the case of Hyperlane, an integrating developer always has the choice of which module to choose from. You're defining how you send messages and how you receive them. And when you define how you receive them, you say, hey, I want to use this module or this aggregate of modules or use this custom logic. In crypto, we generally use the same security regardless of the context of what you're doing. Transferring $10, transferring $10 million, sending a governance message that will completely upgrade the protocol, or you're just initiating a simple deposit, everything goes to the same. Why is that? Why should the same security protocol be enforced at all times, irrespective of context? If there's one thing banks do right, and no one dislikes banks more than myself, the one thing they might do right is this exercising of context-based security protocols. They treat you differently when you want to withdraw $50 and when you want to withdraw $50,000. And you want to close an account, they're going to treat you very, very differently. So what does it mean for someone who's building with Hyperlane right before we get into these use cases? Any type of logic can be wrapped. As long as it provides a state attestation as a state or a state proof as a module, anyone can build a module. And once they've done so, any other developer that integrates Hyperlane can benefit from that module. So you can see how a real network effect in the provisioning of security starts building around these security modules in Hyperlane. So let's talk some use cases. I could do the thing where I could tell you, hey, you could do this with Hyperlane, you could do that, and you can imagine, but let's talk about what's already here, because it's 2024 and it's already a bit more advanced. Aave is using Hyperlane for their interchain governance. When the protocol sees a governance change emerge on the parent, on Ethereum, it uses Hyperlane to message that to Aave deployments on other chains alongside Layer 0 and CCIP. Superform is providing access to yield in an interchain sense. You deposit on one chain and it can earn yield on a number of chains. Mitosis, providing users with access to interchain liquidity. So, again, in the interest of time, I'll rush a little bit, but what's the end game for something like Hyperlane? Well, we talked about how it's an open framework for interoperability. It's not something that one team can build on its own. And in fact, to date, it's already benefited greatly from external contributors. Hyperlane today is implemented and most robust on the EVM, but it's also live and in production with CosmWasm and with the SVM, the VM for Solana. It is about to go into production for the MoveVM. All three of those efforts were either taken to completion or initiated by external teams of contributors. If you're interested in looking into this, check out our bounties, check out our repo, and give it a look. If you're looking for your next job, Our most recent hire is someone who built a ZK module for Hyperlane, picking it off the bounty board. Another is someone who joined us after winning several hackathons, hacking with Hyperlane. Hyperlane is absolutely open to any and all external contributions, and those are what will help us get to that end game where Hyperlane can facilitate seamless inter-rollup interoperability, can facilitate one-click hosted deployments for those who don't want to deal with self-hosting, and can really bring about a seamless interoperability in an expanding modular universe where the number of chains just keep going on and ticking up higher, much like the US national debt. So I hope you enjoyed this. If you have any questions, don't hesitate to reach out, join our Discord, follow us on Twitter, send a DM either to myself or anybody else, and happy to tell you more about it.